Final question in this investigation in row 6 is on diagonal connections. We're really going to study the relationships between the diagonals and the different parallelograms and quadrilaterals that we've studied so far. So they're saying in our earlier work we looked at some different quadrilaterals. We didn't use the linkage strips. We used our GeoGebra interactive software. So what we want to be able to do is complete the following table that relates the conditions on diagonals to special quadrilaterals. So it says this: what if we know the diagonals of a quadrilateral ... and now we're supposed to insert this phrase, bisect each other, then the quadrilateral is a ... So in essence, here's what they're saying. If we have to know the diagonals of a quadrilateral bisect each other, then can we determine what the quadrilateral has to be with any deal of certainty? So what I did is I copied this chart in down here, and what we're given is a characteristic that the diagonals bisect each other. So I'm down in this column here. Well, if the diagonals bisect each other, what figure does it have to be for sure? And it looks like we got lots of choices: square, rhombus, rectangle, parallelogram. But there's only one choice that has to be for certain, or is the only conclusion that you could come up with that would guarantee that you have the answer right. What is the one figure that you would say always has its diagonals congruent and it wouldn't have any other special characteristics about it? And to me, that brings me back to a parallelogram. If I know the diagonals are going to bisect each other, it has to be a parallelogram. It doesn't have to be a rectangle. I don't know if there's 4 right angles in it. I don't know if it's a rhombus because I don't know if the 4 sides are equal in length. And I also don't know if it's a square because I don't know the other characteristics I just mentioned. Does it have right angles? Are the 4 sides congruent? So if I look just at that one clue and it says the diagonals bisect each other, the only thing that I can safely conclude is that I know that it is guaranteed to be a parallelogram. If I make any other statement here, I'm assuming too much. I'm assuming that if I put a rectangle, there are 4 right angles there. That's not necessarily true. If I put a rhombus there, I'm assuming that not only do the diagonals bisect each other, but they had to meet at a right angle. So let's look at some other clues here and see if we can put this into more perspective. In the second one, what if we know the diagonals of a quadrilateral bisect each other and are of equal length? Then the quadrilateral is a blank. So this time they give us a little bit more information to go on. We have a quadrilateral that has diagonals that bisect each other, and they have to be equal in length. So we're going to look down this, probably the most restrictive one. Which ones are they when the diagonals are equal in length? And that is either a rectangle or a square. So they say that they bisect each other and they are equal in length. So I'm down to a rectangle or a square. If those are my 2 criteria, I cannot safely say that it's a square because I still don't know some other facts about that object. I do not know that all 4 sides are congruent. I have no idea what happens about the diagonals being perpendicular as well. So the only safe conclusion I can come to is that it must be a rectangle, because in a rectangle we know that the diagonals are going to bisect each other because we know it's going to be a parallelogram. But the extra added clue in here, they're equal in length, now allows me to go farther than just a parallelogram. It allows me to go to a rectangle. I still can't get to that square because there's some other characteristics out there that aren't necessarily true in this statement that have to be true about a square. So let's take a look at the third one. If the diagonals of a quadrilateral are perpendicular bisectors of each other, then the quadrilateral is A. Now this is loaded. Perpendicular means they have to meet at a right angle and they have to bisect each other. What figures have we studied where if we look just at the diagonals, number one, they're perpendicular to each other? Well, that eliminates it down to just a couple. There's 1, 2, 3, and they have to be bisectors of each other. Now of the 3, are there any up here where they say that they bisect each other? So let's see, the diagonals are congruent, diagonals bisect each other, bingo, bingo. So they're perpendicular bisectors of each other. So now I've got it narrowed down to just 2 choices. It's either a square or a rhombus. The fact that they are perpendicular bisectors of each other should eliminate it down to just 1 choice. So our last choice that we're going to have, that we're going to come up with, they're perpendicular bisectors of each other, is that it has to be a rhombus. We can't say that it's a square for sure because we still don't know if the diagonals are congruent. So there's some added stuff in here that I would be assuming if I put it down that it was a square. So in this one, we want to reply that it's a rhombus. In a rhombus, we know that they're going to be perpendicular to each other, and we know that they're going to bisect each other because a rhombus is a parallelogram. Every time we have a parallelogram, it's going to be a bisector, but the fact that they're perpendicular narrows it down to only two choices, rhombus square. But we don't know anything else about those diagonals, so we're going to name it a rhombus. Otherwise, we'll be assuming too much information. In letter D, the diagonals of a quadrilateral are the same in length and are the perpendicular bisector of each other. Well, last time we had it narrowed down to a rhombus and a square because we knew that they were two things. They bisected each other, so we had a square and a rhombus in on that. They were perpendicular to each other, we were in on that and that. But this time the added feature said and are congruent to each other. That means there's these three criteria that are met. If these three criteria are met, they're congruent, they bisect each other, and are perpendicular. There's only one figure that has all three traits, and that is a square. So this added, the same length, allows us to go one step further than just declaring it a rhombus. And letter E, what if you have the diagonals of a quadrilateral, and they are such that one diagonal is a perpendicular bisector of the other? Now the clue here is that there's only one diagonal that is doing this, and that's really tipping the hand very quickly towards a kite. The kite is the only one that's kind of that hybrid that had those characteristics. It had to be perpendicular. We checked yes on that earlier, so let me wipe these off. So just the fact that they're perpendicular could be any one of these three objects, but the fact that they said only one pair of them bisects the other diagonal, so that's why we're going to come back with the response of kite. So this activity is trying to dig out a little bit more information, make you process it a little bit deeper about what we actually know about the diagonals. And from their characteristics that they tell us about the diagonals, we should be able to decipher what kind of quadrilateral it was. The key is not to go beyond your information. Only work within your information, and don't try to add things in there and say, well, it could be. You have to say, no, I know it has to be. And that's the difference in the thinking on those.